And we are back. Hello there, welcome back. So today I am going to continue working on or trying out this puzzle from Advent of Code 2021. This is day 24, also known as the infamous monad puzzle. And well, this is something that I didn't solve on that year's Advent of Code, and it's the only puzzle that I didn't solve. I actually didn't even try it. So yesterday I started trying this out, and today I want to continue giving this a shot. So what do we have here? Let's close the sidebar. Or where were we actually? Yeah, yesterday we implemented basically the parsing of the program and a function to interpret this program, like run it, with a given set of inputs. And we have this, well, humongous loop that goes from this number of 14 nines back to 0, like in reverse order, and tries to see if any of those numbers is a valid model number for like the puzzle. And this basically never ends. Well, theoretically it should end at some point, but we don't see the end. Like, we don't reach any answer in a reasonable amount of time. I also have this output from another program, which is this is the sample program from the puzzle description that converts a number to binary, which is an interesting one. So okay, this doesn't reach a solution in any reasonable time. So basically, what I think we need to do is what the description says. You need to figure out what monad does some other way. And that's what we need to do. We need to figure out what this program is doing. And I have a couple of ideas or things that I want to try. This program consists of 14 inputs, and the code between those inputs is pretty similar in each case. It is the same number of instructions, and they are actually the same kind of, like the same instructions in the same order. It just changes, like a couple of numbers change, a couple of literals, but the shape of the thing is very similar, which makes me think that this is a pretty simple thing what it's doing here, and I just need to figure out what's happening. So that will be one approach, like to maybe try to read this and understand it, and maybe translate it to like more high-level code, because understanding one of these blocks between each input would probably, unlock the puzzle, and because all the blocks are basically the same, I think, or it seems so. Another thing that might be something easier to try first, I'm going to comment this sample code. Another thing is maybe to try to observe what this thing does to different numbers and try to understand something from there. So here we have this gigantic loop. What happens, for example, if I want to start doing that, maybe instead of going backwards from the highest number, I could also start from the lowest number. This shouldn't be 0 actually, because the lowest bound, like this shouldn't, well, if it's 0, then this, I think, it's going to contain 0 and it's going to be skipped. Like we don't want to have any numbers that contains a 0, and we are doing this to string conversion, and like this is not very efficient or pretty code by any means, but it was just the thing that came to mind most immediately. So one idea would be that, like printing out what different inputs do. Also maybe running subsets, like maybe the first part or the last part of this like 14 blocks. Each of the 14 blocks process one of the 14 inputs. And yeah, we could also try that, like running one of the blocks with, because the inputs each input can only be from 1 to 9, so that is much more manageable, I guess. What we want to have basically is a program or an input that outputs the set variable, which is like here this function returns an array of the 4 variables w, x, y, z, and z is the last one. And if z is 0 after running the program, it means that the input was valid, and that's what we want to find. And we want to find the highest number that is valid. So let's try, maybe here we're going in reverse, which is what we'll probably do in the end. Let's run it with just 100 numbers and print the result and see what happens. So this would be a monad of n is the result. Right, let's run this. No need for release mode. So Z is actually quite big. It seems to be incrementing by 1, something like that. It goes down, okay. Yeah, it seems to be going down by 1. Sorry, I said incrementing, but going down as the inputs also go down. Here there is a jump. Oh, but that jump corresponds to going from 9 to 8 here, which is correct because 90 is skipped. But the number decreased by almost 100. Interesting. And it's the input only decreased by 10. Then it keeps going down. Here there's another jump, similar thing, going by, actually is going down by 95. So one thing that's the shape of the program makes me think is, oh sorry, I want to check something else. Like this is the set variable, but all the other variables are quite low. Well, actually the first variable is w, which are the inputs. So yeah, this basically has the value of this number here. So it's not surprising, like of the last digit, because that's the last input. And I think let's check w. I don't know if you can see that, but when I select a piece of text here, it highlights all the uses of this. So yeah, w is never written inside of the program itself. Only when we're reading input. Then it's used to multiply with x and write to the x variable and to add to the y variable. So I guess w is like it's just local. You could think of this as a function, and w is like a parameter. It's like the input, but it doesn't escape from here. It's going to be a new value for here, and it's only read, never written. Interesting. But z seems to be something that, well, goes quite big. Interesting. And another interesting thing here is that there is this mod x26, which means that x is getting trimmed, or like this is the remainder operation. So here x will get to be a number between 0 and 25. And actually, yeah, look at this. This is interesting. This is a nice trick. Multiply x by 0 is basically setting... Oh, this is cool, actually. Does this happen in every block? Yeah. This happens 14 times. This is pretty cool. So it means that after the input of w, x is always set to 0. So x is never... Like the value of x doesn't carry over from input to input. It's just always initialized at 0. Then it gets added the value of z. So this is basically assigning z to x, like these two instructions. And then x gets to be the remainder of dividing by 26, which is interesting. And then there is something about comparing x. Then something is added to x. This operation of dividing z by 1 is weird because it doesn't change anything. Adding something to x, 11 here, and comparing x to y, and then negating that. Because comparing x to 0, well, if x was 0, so x here is a boolean, whether x was equal to w. And that will only happen if what? If like w has to be quite small, because it has to be, well, w is always quite small, it's from 1 to 9. Yeah. But then it gets added z, which is like the accumulator kind of thing. Huh. And we also observe these jumps when one of the inputs change. Like when the last input is decreasing, it's going down by 1. But then when the second to last input decreases by 1, this decreases by 100. Or no, not here. Actually, here it went up. Huh. But it didn't do that in the previous cases, right? Oh, I think I was reading this wrong. I was reading this wrong. It's going up, actually. It's just skipping a couple of numbers. Okay. Maybe I was confusing there. Yeah, I think I read the numbers wrong. You know what? One of the things that I don't like about this is going in reverse, because I want to understand what the hell this thing is doing. So let's not worry about getting the biggest number first. Let's worry only about understanding this. So I don't want to do a reverse of this. But I guess here, if we want to take 100, this will complain because this won't be 14-digit numbers, right? Yeah, should be a 14-digit number. Nice error checking. So this should not start from 0. It should start from a number consisting of all ones. So let's change that. 1. Okay. And let's actually have the first, I don't know, 500. What happens now? Does this look good? Yeah, I think it does look good. It goes up to 599 and okay, it didn't complain, so all the numbers are 14-digit numbers. That's good. Z is still quite big. Oh, no. Look at this. That's interesting. If we go back to the beginning, oh, there's another block of smaller numbers. Interesting. Interesting. So what happens there? Well, let's see what happens at the beginning though. Here we are incrementing by 1 up to 9 here, and this thing, I think, yeah, it's incremented by 1 up to 57. Then it changes the second place to 2, and it goes from 57 to 49, so it goes back back to the beginning. Like this is the same number as this one, right? Whoops. Yes, it went back to the beginning. That's interesting. And it always goes back to that, except I guess when the magic happens here. What happens here? It went from 7 to 8 on the second place. So 8 is doing something interesting there. And I wonder if this block down 7, 8. So 8 is not doing something interesting here. Oh, but 9 is doing something interesting when the third place is a 2. So in the first case, the third number was a 1, and the second number is a 2. So it went down by like almost 100, like divided by 100, not by 100, but that is like 100 times smaller, this number, give or take. And it did that when the second number was an 8, but then it did it again when it was a 9, and I guess it cannot be a 10, and it cannot be a 0, so we don't see that again, right? We don't see it again. And what is the second to last block, actually? So where are the inputs? Here and here. This is the last, the block for the last input, and this is the block for the second to last input. And look at this, there is a add -8. Interesting. And there is another number. This number, when there is the mod 26. Oh, and here Z is divided by 26. Interesting. Instead of dividing by 1. So how many times does this happen actually? 7 times this Z is divided by 26, sorry. And they are, you can actually see here in the, I don't know how this is called, the editor map. They are, well, not evenly distributed in the code, but in other cases, Z is divided by 1. So yeah, of the 14, 7 times Z is divided by 1, which doesn't do anything, I think, to Z. But other 7 times it's divided by 26, which, well, reduces the Z. But what does it mean for the module? It means if you have something and take the remainder, then when you divide by 26, you're basically discarding that remainder, right? Yeah, imagine if you take the remainder, like the mod 100 from a number, that is basically taking the last 2 digits of that number. But then if you divide that number by 100, integer division, you are discarding those 2 last numbers. So that's interesting. That is interesting. And here, here there's another -8. Interesting, but it's not the last one, the one that we were checking. Does this -8 have something to do with the second, like the second number being an 8 in the first? I don't know, maybe that's not really what's happening here. Maybe I'm seeing patterns. Well, there definitely are patterns, but I don't know if that explains what's happening here. Okay, so interesting. What we want is the final set to be 0. And let's actually do something pretty simple here. Let's just take one of these, and we can print the result, no problem. But we can also print. This is something that I had when implementing the run function, but I think we can print after each instruction what variables are, so we can basically debug line by line. And we can see the final result of this. And if we scroll back, yes, set seems to be like usually growing. And it grows quite large. So my intuition is that we need to find inputs that keep set from exploding, basically. Because, well, actually, let's take a look at what happens with set. So first, the value of set is copied into X. Then sometimes it's divided by 1 and sometimes by 26. So that means sometimes set gets reduced. But then set is also multiplied by Y and then added Y at the end. So yeah, this is basically, set is basically a kind of accumulator. We would need to sometimes, well, here the value of set is read. Here it is written, but division by 1 doesn't do anything. Division by 26, yeah, it shortens set for sure. But then we also need to find like inputs that I think make this multiplication by y, like if y is 0, for instance, this multiplication will leave set as 0. But then, oh, look at this, also y is, this is interesting. Y is also set to 0, and it seems to be set to 0 twice per block. And is this always the case? Yes, 28 times. And look at this. They are evenly spaced out. Oh, that's really cool. So it means that, wait, where is y used? Yeah, y is not used before this in each block, so the value of y doesn't carry over between blocks. It's like a local variable. You know, it actually is like, it's like a literal here, 25. That's interesting. And then it's also initialized again to 0. And the value of w is copied to y, just as the value of, no, not w, the value of z was copied to x before, which is, so z and w are the interesting variables. Z is kind of like an accumulator, and w is our inputs. I realized that this video is going to be like weird because I'm more like talking and not really programming anything, but man, thinking is hard. But this is kind of huge, right? That the variables x and y are basically kind of like locals. Is this thing of, so this is done 28 times, this is done 14 times. Z is now. That doesn't happen with Z, and it doesn't happen with W. Okay. And multiplication happens quite a bunch of times. So thinking about Z, which is the thing that keeps growing, the thing that can make it grow is this multiplication by y here, which y is like a literal, then it gets multiplied by x, and x was a boolean, so that's interesting. Yeah, if we manage x to, oh, and this adds y1, is this also done? Oh, this is done 22 times, weird. So it's done almost every time, but sometimes it isn't. Huh. Oh no, sometimes it is. Like it's confusing with the second addition. Okay, but the add one, let's look for this and, well, regular expression here. What do we want? Dollar. And make it a regex. So yeah, the add one is done 14 times, and add one really looks like kind of like a counter, an integer, yeah, a counter. Like this seems like some sort of unrolled loop or something like that. But after this add one, there is another add of y to a number. So what if we look for add number? Can we highlight all? How does this thing work? Oh, it's already highlighting all. Okay. Why is not highlighting? Oh, because let's say any amount of numbers. Okay. What is happening here? That's sometimes getting confused. Wait. Did oh no, this my regex abilities are quite bad. Okay, so we have three additions of y per block. 25 and 1 seems to be constant. They always do that. So 25 is a very interesting number because it's one less than 26, and it's basically the maximum value. It's the maximum value that a remainder with 26 can have. That's really interesting. That's really interesting. And it's also the amount of days in advent of code, so I wonder if that is also like kind of a hint. I have no idea like what part 2 of this puzzle is going to be about. So okay, let's I want to keep analyzing that, but before going to like maybe try to translate that to high level code and try to understand what the hell is going on. But before that, we know then that Z is accumulating things, and X and Y, they are not accumulating anything. They are like local variables. So we only, like between each input, what survives is the Z value. So we really care about that. I want to, for example, see, let's grab this first part. Let's comment out this and revive this sample and paste the first block of the M-word program. And let's run it. So this only takes one input. Yeah, let's do basically this, but for 1 to 9, 1 up to and including 9. We're gonna do this with n. So we can say n maps to this. We have the other noisy output. Let's comment this out. Okay, so this is basically starting at 7 and incrementing by 1. So after the first block, Z is never Z. Like, I was wondering if there was one value for input that would get Z to be 0, but I guess that's, like, my intuition is that I probably want to have Z, like keeping Z low some way. How do we do that? So this means that after the first block, Z can be one of these 9 values and nothing more, because this is the first input and can be from 1 to 9. So what do we do then? Would it make sense to I'm tempted to do either two things here. Either follow exactly what happens with each of these and kind of calculate like the first one. Like follow the execution of the first block for at least one of these values and try to understand it, or maybe grab the first 2 blocks and do the same thing that we just did, but with all the possible. Sorry, let's highlight this. This is the end of the second block. Let's copy this, paste it here. So this is the first 2 blocks. We can basically N and M, copy the for loop format, and here we are going to execute this. This is going to be the first input, yeah, and M the second one. This would be 9 times 9, 81, and let's also do this, N, M. Okay, I don't know why I run it with release mode. So do we see any patterns here? It goes from 197 all the way up to 413, which we don't have any interesting skips, right? So here it goes incrementing by 1. Here we have a skip when we go up to 2, but it just increments this somewhat. So what would be the pattern? Like 10 here would cause this to be 206, I guess. Or no, I'm not really following like why these jumps happen, but there is no jump down in any of this, it seems. It just keeps going up. Yeah. Should we go one level more? Yeah, why not? NMNOP, how was the alphabet going? A, B, C, D, E, F, G, NMNOP. MN. It's LMNOP. Well, whatever. Let's say O. Yes, why not? A beautiful variable name. Let's go one level more. I want to see if there is one jump like down. Well, this is the same because I have to copy 3 blocks now. So let's copy from here. I'm also wondering if someone might be watching this video and has already realized what's going on and probably looking like an idiot. So now set is getting larger. Does it get shorter at any point? Is there a jump in here? As we saw with the full. Doesn't seem to be. No. Bummer. Okay. Am I doing this right? I'm not sure. I now realize that this loop could have been written like 14 nested loops like this. Would have been fun. It would be look like that Haruken meme of the guy pushing like a cone of if statements or something super nested. You probably have seen that. So what should we do next? Yeah, I want to simplify this. Let's go back to the case when we have only one input and analyze what happens, like maybe line by line, and try to follow it along. Back to n. Because I think I have another idea also, but because I was starting from the beginning here, and maybe I should start from the end, because the end is what I care about. I care about set being 0 at the end. Well, okay, but before thinking about that, let's actually do only one execution of this, just one, and go to this and enable this sort of debug thing. And okay, so this is simple enough, I guess. We should be able to understand it a bit better. So everything starts at 0. the input is 1. Well, that's not a very good input actually, right? Let's just say whatever, let's n be I don't know, 7, lucky number. Let's go with this. Lucky number, but the output is the unlucky one. Nice. So everything starts at 0. Then variable set is copied to x, but that doesn't change anything because set was also 0 at the beginning. Then x is taking the remainder of 26. That doesn't change anything yet. Then set is divided by 1. Again, that doesn't change anything. X gets added, incremented by 11. That does change things. And we ask if x is equal to w. And they are not, because w is 7. So they would be equal if w would be 11, but that cannot be because we can only go up to 9. Yes, unless we had a previous set. If we had that previous set value, but it would have needed to be negative, right? No, like imagine if set was like this. This doesn't matter here because this is the start. But if this was an intermediate block of the monad program, set could have an initial value, as we have seen that it gets accumulated. So for instance, let's imagine if set was 5 there, we would copy 5 here, then take the mod 26 and it would still be 5. This wouldn't change anything. But then it would be 5 plus 11 is not what I want. I probably want to have like -5, so 11, when added 11 it would be 6, and the input can be 6. Well, in this case it's 7, but anyway. Like to make them equal. But I guess if it is negative, it doesn't work, right? Because set gets copied to x and x here would be negative, and the mod cannot work on negative numbers, if I remember correctly. The mod instruction requires that the first value be positive or 0. That's interesting. So that actually means that's interesting too. That basically means that on all of these blocks, we start by copying set to x and then executing the mod 26 with x. So that would be illegal if set was negative. So the carryover value is negative. So set, like at least after each block, it remains positive or 0. That is quite interesting, I think. We don't have to worry too much about negative numbers, I think. Yeah. Okay. So I have an idea. Let's grab, instead of the first block, let's grab the last one. We actually didn't finish analyzing what was happening here. Let's maybe continue on a little bit, although I think it's not very interesting. But here we are comparing x, which was the remainder with 26, and then added 11. We're comparing it to y, and they are different. So false is stored here, but then we are asking if it's equal to 0. So if it is false, and yes, it is false, so it gets converted to true. So this basically is asking, instead of asking x equal w is asking if x is different than w. Okay, and I had a tingling feeling that this is like what Monad does is something like very simple and very logical, but like converted to this sort of assembly thing, it's difficult to see. I wonder if people who read assembly more fluently figure this out really quickly. So, after asking if x is different basically than w, we initialize y to 0, and then, well, we put a literal, basically 25 there, and we multiply y with x. Multiplying y with x can only, at this point, x can only be true or false, like 0, 1 or 0. That's interesting. So multiplying y with x is basically setting it to 0 or not, or to this literal that it had before, depending on the Boolean value. And then it adds 1. So it gets to be 26, which is a very interesting number here. Did we actually, we did see, right, that this add 25 was executed, yeah, 14 times, and then add 1 come on, let me, I don't know what happened there with the input. The add 1 is also 14 times. So when x was true, this is like, which means that x and w were different, y will get the value 26, and in other cases it gets the value 1 after this instruction at least. Okay, and then we multiply, ooh, that's interesting, then we multiply z with y, which means that if y was 1, this doesn't change z, but if y, like at this point, y can only be 1 or 26, if I understood this correctly. So this either does nothing to z, or it increments it by 26, and I think that will be what we want to avoid. Then it sets y again to 0, so that is initializing y again, and it sets y to the value of the input, adds 6, and again multiplies it with x. With x is still like the Boolean value of before. So that's interesting too. If x is false, this will be 0, like y would get the value 0, and then nothing will get added to z in the case that x is false. So okay, so if x is true, then y, no, here this y gets to be 25, and then z gets incremented. So in the case that x is true, this is the bad case for the multiplication case, but it's true. It's also the bad case for the addition statement for z. So we really want this x to be false, which means that we want x and w to be equal, and x is the remainder with 26 plus something that changes on iteration. It starts at 11, then it goes to 13, then it goes to 15, okay, then it goes to -8, 13, 15. The number seems a bit repetitive, or maybe that's a pattern that I'm inventing. No, they are not very repetitive. Well, -15, I think. 14, 14, -1, -8. Okay. Interesting. I feel like we are getting somewhere. What I wanted to do is to execute the last bit, the last input, the last block. Right. Let's do the loop again. And comment this out. Oops, sorry. Just saw my inbox. What did I want to do? This. I keep running this in release mode, which takes more to compile unnecessarily. Well, we have a loop of 1, not very useful. Oh, I think I typed some other shortcuts. Okay, so this goes, like set goes from 11 to 19, which there is a 10 here. Interesting. Okay. This is interesting. So what I want to do, so this is the last block, and we are running this, as a single program, but being the last block means that Z could have, and it probably does have, some initial value, like some value from the previous blocks. So one thing I would probably want to do is let's try different values of Z, like as an initial value. Let's go, I don't know, from 0 to 100 or like to 1000. This will be fast enough, I think. So I need to change this to have like an initial value for these variables, right? And yeah, let's actually extract this. Let result be this. And we're gonna say if result the set variable is 0, so that's what we want, then we're gonna print when set equals the set w equals this n. See that set equals 0 when, let's say, set 0 is this initial value of set. Okay. And and we need to pass the initial value of set to this. So how do we modify this? I guess we can just maybe pass the initial variables here. So let's say initial vars, it will be an array of 4 numbers. Okay, and here we're just gonna pass what? 0, 0, 0. Maybe I can just pass the initial set, but well, it doesn't matter. And set. Yeah, that seems fine. Let's run this and see what happens. Oh, we did get some set zeros, and we got one for each W. That's interesting. Okay. That's really interesting. So it means like for the last block, we could have a final set 0. If, for instance, if the input was 9, if the initial, like if the previous set, like if the reminder from the previous block was 23. And it's interesting also that we went up to 1,000 and we didn't find any other values. So that's also quite interesting to me. In fact, the set zeros are quite low. So here we have -14, and I mean I cannot not notice that -14 plus 15 equals 1. Yeah, which is reasonable, right? We have this 15 before assigned to x, then mod 26, which will leave 15 there. And then we are adding -14, so that leaves x. We're also dividing set by 20. That's interesting. Let's think about that later, but when set is small, like less than 26, like 15 here, we add -14, so this leaves set x to be 1, and of course then is equal to w. The same happens with 16 and 17 and w3 and 23 and w9. That's super cool. And in those cases, like they are equal, so this multiplication by possibly 26 doesn't happen. It gets multiplied by 1. That's awesome. And then this addition of possibly 10 doesn't happen either here. And because this is false. Wait, why is it false? Because they are equal, so then they are not unequal. This is the negation, so x will be false in cases where, yeah, x will be false when these are equal. So we want this to be equal, actually. Yeah. So nothing gets added to set, and set remains 0, right? Yeah, it got. Oh, wait, but what does set get to? Oh no, it gets to 0 because it also gets divided by 26. That's also super important. Once we go past 26, there is no chance of it getting to 0. So the only thing that can get us down to 0 is if this divisions by 26. Well, this always happens. There is no condition over this. Okay. So I do wonder now if we could use this information to propagate back in the program and say like, okay, I can choose W to be 9. I just need that the previous block will leave Z0 to be 23. Right? And that will give us, if we can analyze the previous block, what leaves 23 there. Well, I was thinking about 9 because I want the biggest number, but actually the previous block will be associated with a more significant number than this, so it's more important that the previous one is bigger. Whatever leaves possibly 23 instead is the important one. So let's maybe check that, check the previous one. This also divides Z by 26. It adds -8. I think that this y is kind of the addition of this y is kind of a red herring, or I don't know actually. Like which number in the second to last input would give us, let's say 23 for instance. So let's run the same thing, but for the second to last input, the second to last block, I don't know how to call this, we are also going to have some initial Z value and the possible W's. So this is basically W. But we want the final set to be 23, for instance. So I wonder if this will, again, Alt-Tab to the other desktop. Why am I doing that? I'm not even sure. Oh, because I'm doing something stupid. I'm pressing Alt instead of Control. Okay. Stupid. Renaming not working here. So W is W, yeah. Again, we have different values for the previous set that leave us with 23 in the end. Interesting. We could also choose 9 W to be 9 here. We just need the previous thing. But the thing is that if we keep propagating this back, like none of this Z0 is 0. And at some point we, like for the last one, we would need Z0 to be 0 because that's the initial Z value. Yes. Okay. So, in understanding a bit more, not everything, evidently, but what I understand is that we want to hit these conditions of our inputs being equal to these x variables, which are the remainder 20, the module, like basically the previous z value of mod 26 plus some number. In the first block, we don't have any number that could be that because we start by adding 11. But for instance, in the second block, well, we add 13, so again, we cannot. That's interesting. We start by adding positive numbers, and that screws us up because we don't have any inputs that will make those equal condition equal, I think. Yeah, I think we can't. But then at some point z gets divided by 26, which is useful. That decreases 26, and also x gets at some point gets added a negative number, which in this case we know that we have some w's to match there. So in this case -8. It means that if our w is 8, for instance, no, so if the module, for example, was, I don't know, mod 26 was 9, for instance, then we subtract 8 and it gets x is 1. If our w is 1 here, we can make this condition be equal and nothing gets multiplied with z, as we have seen, and nothing gets added to z. So that keeps z from exploding. In fact, z gets divided by 26. Actually, does 26 dividing x by 26 also corresponds to this being negative? Let's see. Yeah, here it's negative, and the previous one was 2. The previous one is 2, okay. All right. So we found another pattern. It seems like when we decrease z by divided by 26, we also get the opportunity to match the input. That's interesting. So does that mean that in those cases we are forced an input, and maybe in the other cases we can let the input be free and maybe choose 9s for those? I'm wondering. That would be interesting. That would also mean it's only 7, that it means a million different inputs around that order, which is something that we can brute force. Or, well, 10 million, but this, I guess it's less than 10 million because it goes from 1 to 9. 9 to the power 7 possibilities, which is not that big of a number for computers. So it's the same pattern for when z gets divided by 1, so nothing happens. Are the next additions always positive? I think that they are. Okay, interesting. Okay. Very interesting. That's an interesting pattern. So actually I want to do something. Let's have another file here and do a split. What I want to do is maybe translate one of these pieces of code. Actually, there's a couple of things I want to do. I want to first check let's make a copy of this. I want to actually check that these things that we were saying that were the same are actually, like, basically what changes from block to block. So let's replace these inputs. Find all the inputs, just delete them. We know that they are equal on every block. Also, this part I think is the same on every block. Is that the case? Actually, let's close this. Yeah, don't save that file. Yeah, it seems that that is the same on every block, so let's get rid of that too. This we know that it's not the same on every block. Sometimes it is divided by 26, so that's change. The next line also changes, but then we do this. All of this, I think, even up to here, I think it is the same on every block. Is it? Yes, it is. Okay. Then this addition is not the same. That is something that actually changes. And then the last multiplication and addition, I think it is the same on every block. And it is, yes. So if we get rid of all of that, these are the three lines that change from block to block. By which number set is divided, which is either 1 or 26, what gets added to x, and what's the value of y. Okay, so yeah, that confirms our suspicions. Let's go back to the actual input, this. I don't know what these things, like this Windows symbol here means. It thinks it's a batch file. Interesting. Okay. Well, I guess it looks like a batch file. What I wanted to do in this split view is to analyze. Let's analyze what one of these inputs, one of these blocks does. Okay. Let's try to convert this to like code. So W is basically an input. Then we have the x variable, which we are basically assigning z. So z is some other value. Z is like something that comes from, well, in the beginning it is 0, but then it's some sort of accumulator value, h or whatever. A previous value. Then what do we do here? We do x is basically set mod 26 mod 26 plus a number, right? Oh, sometimes, okay, sometimes this is divided, but that doesn't affect x. So plus a number, 11 in this case. And then we compare x and w. And this boolean, let's call it, I don't know, a boolean b. So this gets assigned to x, but let's not use x for another thing. Let's use other variables. So if they are equal, but then if it is true if they are unequal, because of this negation, which is the same. Yeah, we wanted x. What did we say? That we want x to be false, actually. So we want these things to be equal. So y, the y value here gets assigned 26 or 1 and multiply to set, basically. So basically here what we are saying, if that, let's convert this into an if statement. So if x is equal to y, let's do it kind of, yeah, Python-esque or pseudocode-esque thing. If x is equal to y, then here x gets to be true in here, then false in here, and then it means that y ends up being 1 and nothing happens to z. But if they are not equal, it means that z gets multiplied by 26. So this is kind of the condition. In the case that it gets multiplied by 1, I don't care about that, it's like nothing. And also, then we have another y here, but this is basically like another variable. We add w to y and we add 6, okay. And we multiply this with x. So again, if x means that they were different, so this will be something. If they were different, it will be this number and will get added. So if they are different, z also gets added the value of y, which is w plus 6. And this number 11 and the 6 is what changes. So I think that this block basically means this pseudocode. And it's more clear that we want x to be equal to w, so this condition doesn't apply. Okay? Interesting. Save this file as, I don't know, pseudo.txt. These are the things that change from block to block. So here we can see that x is going to be a value that is greater than 11. Greater or equal than 11 always, because, well, actually greater, because z, no, z is the accumulator. Mod 26 could be 0, I guess, but the lowest x can be is 11, so we can, it's always going to be different than w, because w goes from 1 to 9, is the input, and so this will always happen in the first block. And I guess it will always happen when we have when we are adding numbers here that are bigger than 9, I think, because when it is 9, yeah, I guess we could have a w that is equal to that. So let's see actually what are we adding we can remove this space. After the division by 1, here we are 13, so it's also greater 15, 13, 15, 14, 14, 11. So there are cases where we cannot avoid this set getting big. We cannot avoid that. But then in other cases, those are the cases where set is divided by 1, so nothing happens. But in other cases, set gets divided by 26. And in those cases also we can avoid the increment of set. And I think then, therefore, we must avoid them in those cases. Because we have 7 cases that it gets increased by 26, and we have 7 possible cases that it gets divided by, or as I said, decreased by, multiplied by 26, and we have other 7 cases that it can get divided by 26, so we must do that. That's interesting. And I think in those cases what we have seen is that we basically have one possible input for each possible value of previous Z. Right. So let's check. Here we have the first, the second, the third blocks are those cases where we can't avoid Z from growing, right? But the fourth one is the first block where we can avoid it from growing. So we're going to do mod 26 and then subtract 8. So we need that mod 26 minus 8 to be a number from 1 to 9. So we can put an input that is equal to that. Yes. So I wonder how we can do this. I'm glad that we did this kind of analysis. I think it got things a bit more clear, but still don't understand exactly how this works. Here we need the previous set mod 26. Since we are going to, so that will be a number from 0 to 25. We are going to subtract 8 from that. So that will leave a number from 0 to 17, if I'm not mistaken. And we want that number to actually be from 1 to 9, so we can make it equal to W. And that basically depends on the inputs that we had before, like what will this mod 26 be. Each of the previous inputs is going to make, I think, only one possible value for this W. So I think that what we want is to maximize the previous inputs, like to get the maximum of the previous inputs that matches yeah, that makes this thing go down, I think. Something along those lines. I think I'm getting into something, and I will continue that train of thought, but I need to go to the bathroom and I also want to take a break. So that will be it for this session, and I will continue exploring this afterwards. This is a very weird video if I get to upload it, because we basically did zero code but 100% analysis, I guess. So that's it for this video. Thanks for watching and see you later. Bye.